So this one will be due. So first thing, you can see the dates here are incorrect. I think these are probably directly copied from last year. So the dates are, you can see the dates, the due dates on Canvas. So the part one and part two, part one is due 28th. That's still a reasonable date, but I think the second one could be too soon for you guys. So I'm gonna move this one to Tuesday because March the 31st is a Monday. So we're here. So Tuesday we have a lecture time and lab time. So it's a significant amount of time adding to it. So hopefully that'll be helpful for you guys. Okay, so I'm gonna move the time here to Tuesday instead of Monday. So this will be Tuesday. Okay, so disregard the times here, okay? None of them make sense. I'm going to change it right after this. So there are a few things you need to know. First, if you are looking at examples, so these are all from the packages you can download from here. You download it, you can open it up, and you see all these scripts in the package. It's available. And these are from the textbook. And you can see it uses some of the keywords. Button is not a button we have in the constraint file. Ours is like a button L, right? L, R, T, B, and C. So this is our buttons constraint file's name. And AN, yes, ours is AN. Switch is ours is switch. You don't have to change it. But for SS SAG, so ours is like just SAG, right? So the reason for that is they used a totally different platform. It's also from Xilinx, but it's a different IPGA. So the IPGA uses a different keywords in the constraint file. And also this is based on the KCP SM3 CPU, which has a 9 bits, 10 bits of address. I think ours has 11 or 12. So you need to make the certain changes over here. You need to make changes to the ones I marked here at least. Okay, these ones. You need to delete these and change these. Okay, so this is the example of the KCP SM6 core. That is your program, right? It's your assembly program. Don't forget to change these the names of your RPGA. And we had a issue with another student who cannot find the problem over here, but eventually he forgot to put the quotation sign here, and it took me forever to debug that. Okay. You need to make some changes to the constraint file. So the constraint file, we are not using the DP. So DP will be used as the 8th 7-second display LED. Okay? So you need to change it to SEG 7. So eventually the calculator is doing multiplication, and we went through the multiplication assembly code last time. Remember, we had a in-class exercise, and you guys have a quiz on that as well, right? So hopefully everyone understands that core algorithm. That's probably the only thing worth mentioning in the assembly code. But all the rest are just moving data back and forth to the registers, but nothing else. So if you understand the multiplication, I think the assembly code shouldn't be a problem. And you can see A square is also a multiplication. It's just A times A, right? So B square, same. And eventually you get the results, you do addition. Addition is pretty simple for us. And it has the different switches to choose which one, so the data is being put into which variable, okay? And I have everything explained in the video here. You can watch the video, have all the procedure regarding how to operate that calculator, okay? It's basically you have one, it's doing A square plus B square, okay? It's a square problem. So you need to do a multiplication first, and then another multiplication, and then addition, right? So, but the thing is, there's no place to show you that when you are loading data to A or B. So in that case, you need to do a A first and push the button, so you load the data to A, and then do another data, press another button to load the data to B, and eventually it runs a calculation. So task 1, you can see the first section is pretty much everything from here, from here to the top. So task 1 is just everything displayed in the tutorial, in the demonstration video. So just go through the video and try to duplicate whatever I did over here. It should be really simple because the code already provided to you. You just need to change some of the parameters, like I marked in the pictures above. And for the second one, it's a minor modification. So instead of displaying the data to the 7th segment, you are also throwing the data to the LEDs as well, so also displaying the numbers to the LED. And the last one is the LCD. It could be a little bit more challenging. That is why the last one is for week 2. So I'm giving you more time to work on that because you have to include another module to it, the LCD module. You already did the LCD previously, so you just add there's a lot of wiring, right? So I know it's going to cause a lot of problems for you guys. So that's, I think that will be another 100 points instead of 50. I think I put 100 for each, right? So you can see, yeah, on Canvas it's 100 for each. Sounds like it's just one lab, but actually it's 2 labs. It's 100 points for each. Try to make it fair because a lot of workload here. Again, so for the ones who stepped into the classroom later, I mean, these dates are incorrect. Disregard that, okay? It's basically just the interface, right? If you know the input and output of the LCD module, whatever for the code already generate the result, and then use that result as an input for the LCD module and display it to the module. Yeah? Should be pretty straightforward, right? I didn't see major issues from the past. So as long as you guys are given with enough time to work on it, it should be able to figure things out. Any question on this? So I will stay in my office instead of staying here in the enclosed area. I'm sick. You can come and ask me any questions if you are brave enough. Yeah, sure.